talking about lesson 7 and 8 and being experts on it. Now we're going to advance. You guys agree? So this lesson and the next lesson we're looking at sinusoidal functions, which is basically the graphs of sine and cosine in real life. Okay, I'll just read first little blurb. So the graph of the sinusoidal function is called the sinusoidal graph, and you might see that in examples such as time of sunrise as a function of the day of the year, the height of a chair of a Ferris wheel as a function of time, or the depth of the ocean. And those are actually all examples we're going to be looking at. In this lesson, we're just going to be given the equation and we're going to interpret what's happening from that equation. And then next lesson, we're looking at the graph and we have to derive the equation. Okay? So similar to what we've done in lesson 7 and 8, but this time we're putting some real life applications to it. So in the first example, the depth d meters of water in a harbor t hours after midnight can be approximated by the function d of t equals 12 plus 5 cosine 0.5t, and we have a domain between 0 and 24. So to figure out the maximum and minimum, I'm just going to remind you guys of the cosine functions. Okay, so along the y-axis, we would start with the maximum of 1, go through the x-axis and back up to its maximum, and we'd have a minimum at -1. Okay, if we look at the equation, we have an amplitude. That's basically our vertical stretch factor. So if I were to have a vertical stretch factor of 5, our max and our min would now be at 5 and -5. Okay, and then what does this plus 12 do?
Up 12.
Okay, we're going up 12. So we would take our minimum and go up 12, and we take our maximum and go up 12. So now we have our max and our min of our graph. So the max is given by a plus d in your equation, okay, where this is your d and this is your a. Okay, so our a is 5, our d is 12. Add those together, we get 17 meters. And our minimum will be the negative value of our amp. So negative a plus the vertical displacement d. So we get -5 plus 12. And that gives us a positive 7 meters. Okay, so that's the max and min of our graph. Okay, now let's figure out what is the period of the function. So given the equation, we're going to find that from our b value. So given it's a cosine graph, our period will be calculated by 2 pi over our b value, 0.5. Maybe I'll write that up. Our b value, so we get 2 pi over 0.5. Or 2 divided by 1/2 is actually 4. So we get 4 pi. Now for part C, we're asked to write a suitable window for this, and I'm just going to let you know right now, anytime you're dealing with sinusoidal functions, typically you're going to be in radian mode. Okay, so we're going to write window settings for radian mode. Let's talk about our x. Okay, the minimum x value, I always like to see the x and y axis. So although the domain goes from 0 to 24, I might just go -1, 25, and then I'll go up by a scale of 1. So that's along the x-axis. Okay, and x is going to be our time, and y is going to be the days. So along our y-axis, we just have to consider our max and our min. The max is at 17, our min is at 7. Like I said, I always like to see the x and the y-axis, so I'm just going to go -1, and then up to 20, scale of 1. Okay, so before we start answering
Junior class change.
the other questions, let's just practice graphing this. Everyone needs a calculator. Does anyone need one? Okay, we're okay. So first of all, we have to check our mode, make sure we're in radian, and I am, so we're good. Then we're going to go to our window settings and put them to the settings that we just defined. So -1 to 25 and 1. And our y min will be -1 to 20 to 1. Okay, and then we'll go into y equals and we'll put our graph. 12 plus 5 cosine 0.5, and in this case our t is going to be an x. And we can go ahead and graph it. Okay, so we have our function described here in the graph. Let's just reread what they tell us. They say the depth, d meters of water in a harbor, t hours after midnight, can be graphed by the function given, and we're between 0 and 24. So if time is t hours after midnight, what hour is right here? 0-100. Is that how you say it in the military? 0-100 or whatever. Anyways, and then all the little ticks after we're going up by a scale represent hours. So this would be 1 a.m., 2 a.m., 3 a.m., 4 a.m., 5 a.m. So in part D, what is the depth of the water to the nearest tenth of a meter at 2 a.m.? If this is my t-axis, what will t equal? 2. So t is going to be equal to 2, and there's two ways that we can solve this. We can go d of 2 equals 12 plus 5 cosine 0.5 times 2, or you can graph it, and we can solve for the value of x equals 2. So algebraically we can calculate that, or you can just go second trace, number 1, and we're going to put x equals 2 in there. Let's see what we get. Okay, so we're getting the ordered pair 2 and 14.7. So to the nearest tenth of a meter, at 2 a.m., the depth of the water is at 14.7 meters. And hopefully you guys have been close to the ocean before, but if not, you got to get out there on your holidays. But the depth of the water, as the tides come in and out, is going to change the depth as it's closer inshore. Okay, so that's what's happening at this harbor. And at 2 a.m., the depth is at 14.7 meters. Now it's important for sailors and anyone with a boat to know this, because if they're bringing their boat into the harbor, they have to know when it's going to be grounded. So if there isn't enough water in there, then the boat might get stuck there. Okay, so you can't actually sail it out, it'll be stuck in the sand. So it tells us that a ship requires a minimum of 8.5 meters of water to be in the harbor. By what time to the nearest minute must it leave to prevent grounding? So what we're going to do is we're going to put in a y2, and our y2 is going to be at 8.5 meters. And we're going to figure out, okay, this is midnight, okay, at what time will they have to take the boat out? Because anything underneath this line, so anything under 8.5 meters of water, that's going to be grounded. Okay, there won't be enough water for the boat. So we've got to figure out what time does that boat need to get out of the harbor. So in your y2, you're just going to put 8.5. Yeah, it's a little bit off. Okay, so we've just got to figure out this intersection point. So we're going to go second, trace, number 5, and move that cursor all the way over and get to that point. So obviously our y will be 8.5, but our x is 4 point, actually maybe I'll write this out. So y1 is our graph, 12 plus 5 cosine 0.5t and our y2 is 8.5. When we intersect, we're getting 4.6923 and our y value is 8.5. Okay, we care about the x coordinate. So just the whole number of this, 4, what does that represent? How many hours? So what time would that be?
4 a.m.
4 a.m. Good. Okay. Now this 0.6923, etc., that's in hours as well. So we've got to take our decimal, okay, 0.6923, etc. We've got to multiply that by 60 to figure out how many minutes it is. Okay, so let's do that. If you want, what you could do is just quit out of here and press X, then enter. And we want to subtract that 4 out to just figure out the decimal. So the decimal times 60 equals 41.54, 32, etc. Now, I'm just going to pull the graph back out, and we're going to talk about that number. So they want us to round to the nearest minute. Now, if I round to 42 minutes, because that's typically how we would round a number, is round up when it's 5 or more. If I went to 42 or 442, that means I'm in the grounded zone. So we wouldn't have enough water for this boat. So in this case, I actually have to round down so that the boat can free itself. It doesn't have a chance if it goes to 42 minutes. Okay, so the correct time for this, we round up, round down. And we would have to leave at 4:41 a.m. Now, any questions so far? I'm seeing some shrugging shoulders. Are you confused why you round down?
No, my knuckles.
Oh, you just cracked your knuckles.
No,
Okay.
Yeah.
Just making sure.
Do,
You must have felt satisfied then.
Yeah, it was
Yeah,
nice.
got it.
are we ever gonna have to do that part algebraically?
Where you have to solve algebraically?
Like the intersect, yeah.
Well, you guys could. It would go back to the first 4 lessons of the unit. You would just have to set this equal, subtract the 12 over, divide by 5, and
How do you get rid of
how do you get rid of the cosine? Then you would, actually in this case, because we have a stretch factor, you can't exactly do that. Okay, because we wouldn't have t isolated with the cosine, so in this case, because we have the stretch factor, you couldn't solve that algebraically. So just graph these ones. Okay, part F, I'm just going to leave the screen as is and we'll talk about it. So what is the next time to the nearest necessary minute that the ship could come back to the harbor? Okay, so right now, no ships are in there. When it's grounded, when the depth is below 8.5, no ships. Okay, unless they plan on leaving it there for a while. But if they want to leave, they got to make sure that they're not grounded. So right here at 4:41, no one's there. We've got to figure out the next time. Okay, so we're going to find this intersection point now. And that's when the ships can all come back. So second trace, number 5, for intersect, and just move your cursor to that second intersection point. So here we're getting an intersection point of 7.873983, etc. And our y value would be 8.5. So the 7's telling us it's at 7 a.m. Now we've got to take that 0.8739, etc., and multiply by 60 to figure out 7 hours and how many minutes. Okay, let's solve for that. So just a little trick here, if you don't want to rewrite everything, you can quit out of here. Then we're going to go second alpha, number 1 for y. Press enter. Sorry, I need the x value. X, enter. My apologies. Subtract the 7, and then multiply by 60. So this could go one way or the other. We could say that it's at 7:52 or at 7:53? I'm going to go back to the graph and we'll talk about that. So at 7:52, still grounded. We need to be at 7:52 and so many seconds to get out of that. So instead of rounding down to 7:52, we actually have to round up because when we're at 7:53, the water depth has now gone up again. Okay, so it's kind of opposite depending on where the curve is. So for part F, sorry, I'm running out of space here. Okay, we need to round up, and we can go back into the harbor at 7:53 a.m. So with these types of questions, you really have to think about the scenario for when you're going to be rounding up, when you're going to be rounding down. In this next question, we're looking at a certain town in Alberta and the time of sunrise for that town. And it's going to be looking at any day in the year. Okay, so the equation's given to us, and we just have to make a few interpretations from that equation. Just erase this all first. Okay, so within this equation, T is the time in hours after midnight, and D is the number of days in the year. So we need to figure out a suitable window settings for this to display the function. So again, we could look at what is our max, what is our min. You guys help me out, find your max. That's going to be your A plus your D. Now we need to find our min, which is your negative A plus your D. And truthfully, you always want to show the x and y axis, so you only really need to find your max. We have 8.09 as our max, and 4.51 is our min. Okay, and so this will help us for our y-axis. For our x-axis, D is the number of the day in the year. How many days in a year? 365, very good. So our window settings, okay, for x, let's go -1. Someone else already said that because of leap years. What is it? 365 point?
364.25.
Yeah. Which class are you talking about this in?
I just knew
You
that.
just knew it. Very good. Okay, so -1, and we'll go, let's just go to 370. We'll go a little bit over a year. And we probably don't want to scale up by 1 because our graph is just going to be really small. So what should we scale up by? Maybe 30, 40 days?
Sure.
Let's do 30 days. Okay.
Did you hear what he said?
And our y scale, keep in mind our max is at 8.09. So let's go from -1 to 10 and we'll scale up by 1. And if you guys really wanted to find the period for this, for what one cycle would be for this, this is your b value, and the period for sine would be 2 pi over the b value, which is 2 pi over 365. So what is the period of this function? 2 pi's cancel out, 365. So we've got our window setting very appropriate for one cycle. Okay. So why don't you guys graph this? Okay, let's put it in our calculator. Let's get our new window settings. We have -1, 370, and a scale of 30. And then for y min, we're going to go -1 to 10, scale 1. Don't forget to change your y equals.
2 pi times bracket.
So you want to be careful with your brackets here. So I'm going to put in one set of brackets 2 pi divided by 365 multiplied by x minus 78. Close that bracket and then close the other bracket. And then add 6.3. So just leave that for a second.
Why did you put the 2 pi divided by?
So this here is my b value. So I wanted to just put that separate. I've got sine 2 pi divided by 365, that's just my b value, multiplied by the x minus 78, and then I've 78, sorry, and then I've closed all those brackets. So these are my brackets that close everything. This is my bracket for my b, and this is my bracket.
You multiplied the x plus 7.
Yeah.
Or x plus 7.
That's what I got last time.
Could someone let these little cuties in? Thank you very much, you guys. Whenever you're set, we can hit graph. Maybe press enter to.
I don't think this is right. Bernie, what's yours look like?
Mine goes off the screen, so.
Is that what yours look like?
Yeah, mine's on.
Is that right?
Yeah. Oh, the same.
Yeah, same thing, but that's it.
Mine are the same.
Oh, my y max needs to be at 10. It's like, why isn't this graph showing up? Make sure your window settings are good to go.
There you go.
Now we got it.
It's
I'm
going
gonna
on.
move this just down here so we can talk about it.
Almost not gonna find those.
Okay, did everyone get their graph? Where are we going?
Yes.
Yeah? Okay. So when I went to graph it, nothing showed up. So you want to troubleshoot. Look at your y equals. Did you put that in correctly? Then I looked at my window settings and I realized my y min was at -1. My y max was at 1. Okay, my y max I wanted to be at 10. So I just made a little mistake. And let's look at our min. It starts at 4.51. So if I had a max of 1, I wouldn't see the graph. So just be careful with your window settings. For part B, we're going to now use the formula to determine the nearest minute when the sun rose on the 127th day. So, let's actually first talk about the axes. Okay, we have two axes. T equals. So that means the y-axis will be time. Okay, time of day. And then the x-axis will be the day number. So if we're looking for the 127th day, that means D has to equal 127, or X has to equal 127. So we can just trace. Sorry, I'm just going to move this up for a second. Okay, you can go second trace, number 1 for value. And when X is 127, what hour are we on? Well, we're for something. We need to do a little conversion to figure out the exact time. So there's two ways we could have done this. We could have gone t equals -1.79 sine 2 pi over 365 times 127 minus 78 plus 6.3. You could have just put that in your calculator. Or like we did here, we traced it. And the value we get is 4.96292. So we know it's going to be 4 something a.m. We've got to take this decimal now and turn it into minutes, because right now it's in hours. Okay, so 0.96292 times 60. See what we get? Okay, you get 57.775. And they want it to the nearest minute, so we're just going to round up. So 57.77 rounded up would be 58. So at 4:58, that's when the sun is going to rise on May 7th. Pretty early. Summertime. More sun.
Day 54, day 53.
Okay, let's see how you guys are catching on. For the last part here, we need to figure out on which days did the sun rise at 7 a.m. So what are some strategies we could use to figure that out? Keep in mind on the y-axis it's time, x-axis number of days. Brilliant. Okay, that's exactly what you do. Brilliant. The British is rubbing off.
Good at it.
Okay, so y2 we put to the equal 7. Then we're going to get this beautiful line across. Okay, so if this line represents 7 a.m. all the way across here, then there's going to be 2 days in the year, right here and right here, where the sun rises at 7 a.m. So to find those 2 days, we just need to use our intersection. So second trace, I'm going to move my graph up. Number 5.
54.7.
And they just want to the nearest day, so let's pick the nearest day. Alright, so if we're at 54.6, the nearest day would be 55 days. And then, did you guys find the other one?
No.
Okay, we'll do that next. Day 55, and move your cursor all the way over. 284, let's see if you're right.
Oh, yeah.
I believe it.
Oh, I don't.
283.84, so to the nearest day you have 284. Okay, so day 55 and 284. 7 a.m. Okay, perfect. Any questions? No? So a lot of these questions are just understanding the scenario. And once you understand that, it's really easy to use your calculator as an aid to find the answer. Lesson 10 is a little bit different. We're given the graph, and we need to now come up with the equation. A little bit short on time for this one. So,
That's so weird. Literally the shortest lesson ever. And it's,
you guys took a long time on your quiz.
what's the study time?
Let's do the review, and tomorrow we'll just do these other examples. Okay? Tomorrow's a review day anyway, so we can just do those. Still in negotiations. I'm thinking Thursday.
Oh, yeah.
So will we write when we get back?
Maybe I'll send it on the road.
Oh, please don't.
We'll see. I'll probably just have you do it when you're back.
I don't know any of
I mean, you got 3 days to work on it.
Okay guys, we only have a few minutes, so let's do the review. So here we have a sinusoidal wave, and the maximum value is 50, the minimum is 10. We have to figure out what the equation is. This is pretty much review from lessons 7, 8, so hopefully we can do this. First of all, how do I figure out my A?
Max minus divided by 2.
Well, we don't need a monotone voice, do we? It's that exciting. You're max! Okay, 50 minus 10 over 2, we get 20. Okay, 20, that's our A value. Or M. Okay, while we're on our max and mins, let's do our vertical displacement. That will be max plus min divided by 2. So we have 50 plus 10 divided by 2, we get 30. That's our D value. So we're halfway there. We've got our A, we've got our D. Okay, we're talking about the graph of sine. So next we could move on to our horizontal phase shift, or we could talk about the period and then solve for B. So, graph of sine, let's actually write our midpoint first. Okay, that's going to be at 30. So sine would start here, it would go up, down, and then back. So looking at if that's our starting point and that's our end point, to calculate the period, we could go 48 minus 16. Okay, so the period is equal to 48 minus 16. And that's 32. Now another technique, just to talk about it, is, I'll just ask you guys quickly. Would you guys say that this graph of sine, where A is positive, is the same period as this graph of sine when A is negative? Is the period the exact same? Yeah. It's the same length long, right? So if you're looking for period, you could also just look at the reflection. The reflection starts on the y-axis. Goes down, up, down, and where's it at? 32. So that's 2 ways that you can find your period. Okay, now that we have our period, we can calculate our B value. That's going to be equal to 2 pi over the period of the graph, 32. So we get pi over 16. That's B. And lastly, our horizontal phase shift. Okay, where are we moving? Normally we start halfway, so we would have had to move over 16 spaces. So our horizontal phase shift is 16 right, which means C equals 16. So we have our A, our B, our C, and our D. So the equation will be y equals 20, because that's our amp, times sine, times our B value, which is pi over 16, times T minus our horizontal phase shift, which was 16. Close the brackets, and we've got to add our vertical displacement, which is 30. So that's just a little bit of review.